All right, guys, pretty quick video today. Well, at least it should be. We'll have plenty of time for a few examples. But what we're talking about today is how to factor something called the difference of squares. Now, remember, this symbol right here in the middle, that minus sign, that's what gives us the difference part. Remember, difference means subtraction, okay? So if you see two numbers being subtracted, and the first term usually looks something like x squared. And there's not the middle term like what we had before. In fact, this is just something, we call this a binomial because it has two terms. And it usually looks something like x squared minus 16 or x squared minus 36 or 4x squared minus 81. You usually have something squared in the front, which is what you get right here, this a. Something's being squared, and it's usually a variable. Sometimes it has a number in front of it. But then after the minus, you have something else being squared, like 16 or 36. And remember, so when we keep saying perfect squares and squaring, remember that a perfect square, this only works when you have perfect squares. And perfect squares really just means that you can take the square root of the number. Okay, a perfect square means you can take the square root and get something nice. X squared, whoops, that's not what I wanted. X squared is a perfect square because the square root of x squared is x. 36 is a perfect square. The square root of 36 is 6. 81 is a perfect square. Square root's 9. 4 is a perfect square. The square root's 2. So what we're going to do today is, if we have this situation, we can kind of shortcut the whole process because here's what happens. What we're doing with this is we're going to basically take something that looks like this and we're going to shortcut and turn it into something else. And when we're done, it's going to look like this: a plus b and a minus b. And that's actually going to be our answer: a plus b and a minus b. Now, the reason this works, just to show you what's happening, if I FOIL, a times a is a squared, a times negative b is negative ab, b times a is a positive ab, and b times negative b is negative b squared. So what happens is these two in the middle, this negative ab and this positive ab, cancel each other out, and you're just left with the a squared minus b squared. So knowing that, it's really easy to work backwards and turn it back into this factor, these factors. You are more than welcome to do it the long way, like we have been doing, but if you recognize this shortcut, great. So step one, just like before, greatest common factor. Is there a greatest common factor? Always check this first, because you won't get it wrong if you don't do this first. You'll have to factor later, but you'll be using a lot smaller numbers. And if there's a greatest common factor, remember, pull it out. And the great thing about it is you can just ignore it for a while. You pull it down. So for example, I think both of these examples right here have a greatest common factor. This one, if I'm looking at 81 and 36, 9 goes into both of those numbers. So if I have 81x squared minus 36, I can factor out a 9 because that's my greatest common factor. And what I'm left with, we practice this quite a bit, 81 divided by 9, I still have 9x squared left over. And the negative is going to stay here because 36 divided by 9 is 4. So for just a minute, this 9, I'm going to go ahead and pull it down here, and I'm going to ignore that it was even there. We know it's there. We just dropped it all the way down here to our solution. Now we've got to figure out what goes in our two boxes here. Now, if you're looking for perfect squares, you might recognize, well, I guess that's really step one right here, is what's being, W-H-A-T, what's being squared? That is an I, don't worry about it. What's being squared right here? So what we're looking for is what would that A be and what would that B number be? So when I look at this right here, when I look at 9x squared minus 4, what's being squared? In this one, the 9 is being squared, or something is being squared to equal 9. Sorry. So we want to take the root. We want to take the square root of both of these, and that's going to help us find A and B. All right. So if I take the square root, let's use a different color here. If I take the square root of 9x squared, so the square root of 9x squared is going to equal the square root of 9, which is 3. The square root of x squared, that's just x. And that's actually my A term. That's what's going to go right here under A. So I'm going to just put that in right now. 3x is going to go here. 3x is going to go here. And now if I square root the B, the square root of 4, well, that's easy. That's just 2. And that's going to be my B number. And when I put that one in, the first parentheses, I put a plus. Not plus B, plus 2. The second parentheses, I put a minus 2. All right, so we're going to plug in, after you find what the roots are, you're going to plug in A and B. And the formula, just so that you know what you're using here, don't forget it's A plus B times A minus B. So once you find A and B, you just plug them in, all right? And then as always, you can check yourself, you can check your work just by working backwards. So in this case, I would multiply these two together, I would FOIL, and then everything would have to get multiplied by 9. And if I end up back where I started, then I've got the right answer. So those middle terms, remember, they should eliminate. Should eliminate those middle terms when you FOIL, okay? Before we get down to this example, I want to do a couple different examples. We'll come back to it. Don't worry. You should have plenty of space here to take extra notes. But let's start with something a lot simpler. Let's start something like x squared minus 144. Now, there's a couple of hints here that make me think I might use the difference of squares. First of all, 144, that's a pretty common square. That's 12 squared. So that looks familiar. And not only that, but there's nothing in the middle. Notice that there's no, usually we have something like x squared minus 3x. Well, there is no 3x. That term is missing. There's nothing in the middle. So that gives me a hint that this might work. It doesn't always work, but it might work. So step one, always, well, I guess pre-step one, greatest common factor. Nothing common between x squared and 144. So we don't need to worry about that. So we need to look at what is being squared. Okay, so I'm going to take the square root of this and the square root of this one. And when I take the square root of x squared, I get x. And when I take the square root of 144, I get 12. So this is my A and this is my B. And now all I have to do is plug them back in. So A plus B multiplied by A minus B. And I'm done. Well, I'm done. You're not done because you're going to check your work and make sure you've got the right answer. All right, let's do another one. What if I have, let's put something back out in front. What if I have 16g squared minus 9? Again, there's kind of a hint. I've got nice square numbers right here. These are perfect squares. I know those. And I'm missing that middle g term. There's nothing multiplied by g. So first thing I'm going to do, greatest common factor. No greatest common factor, so I don't need to worry about that one. Second step is, or I guess the first real step, what's being squared? What is going to come out underneath these square roots? So when I have the 16 and the g squared, the square root of 16 is just 4. The square root of g squared is just g. I'm allowed to do that because there's no plus or minuses under here. And the square root of 9, that one's easy. That's 3. So here's your A. Here's your B. So now when I plug those back in, I'm going to get 4g plus 3. multiplied by 4g minus 3. Okay. Let's go back to this example over here. I don't want to get too far ahead of ourselves. There's a reason that it's here. I want you to know a lot of what you're going to see in the work and in the homework and stuff like that is going to be more like this one here. But that's not always the case. Sometimes that difference of squares is hidden. You don't see it quite so easily, especially in a problem like this one. If I look at this, I've got 32. What we're working on right here is this one. Okay, I've got 32 x to the 6th power minus 72 y to the 4th. Now, at this point, I don't really see any squares. That just looks like nonsense. So the first thing I'm going to do, greatest common factor. So what goes into 32 and 72? 2 does, 4 does, 16 goes into 32. I don't think it goes into 72, but 8 works. So 8 goes into both of these. So if I factor that out, 32 divided by 8 is 4. And I still have x to the 6th. And I still have a minus. 72 divided by 8 is 9. And I still have a y to the 4th. So my greatest common factor, I'm going to go ahead and drop it down here to the bottom. And I'm just going to ignore it for a minute. I'm going to forget it's there. And I'm going to focus on what I have left. 4x to the 6th minus 9y to the 4th. Now, you don't see an x squared. And this, you definitely don't see an x squared. We've got y to the 4th power. But be careful, because if I take the square root, right, that's step 1. If I take the square root of both of these, the square root of 4 is 2. And if I take the square root of x to the 6th power, hopefully you remember how to do that. That's x to the 3rd. I'm just dividing it by 2 when I take the square root. And that gives me a pretty nice number. So that could be my A. Now let's check for our B. So I've got the square root of 9y to the 4th. The square root of 9 is 3. The square root of y to the 4th, again, just divide this in half. And I get y squared. That's going to be my B. They're perfect squares, even though they don't look like it because of these variables and these exponents right here. But all I have is my A is 2x cubed. And my B is 3y squared. So I'm going to put plus 3y squared. And then I'm going to put minus 3y squared. So sometimes the difference of cube is kind of hidden behind some other math going on. This is something that you'll probably see on the AB assignment a little bit more. We won't use that a lot in the class this year just because it's not something we're going to have to deal with. But it is something that they like to throw on the ACT. So those of you that are kind of keeping track of things for the ACT, you might want to mark that one. That's going to be the kind of thing that they like to test you there. All right. So go ahead and get working on the homework assignment, and we'll see you in class.